Hello. The title of this course is Fabrication and Characterization for Top-Down and Nano Manufacturing. My name is Osama Al-Karim. I'm a professor of engineering science and mechanics. I'm also the director of the Center for Nanotechnology Education and Utilization at the Pennsylvania State University. At the beginning of this course, I would like to go through the outlines of the course and discuss the topics that will be covered in this course. First part of this course will be discussing materials for manufacturing. And in materials for manufacturing, we will be looking at single crystals, polycrystalline solids, and amorphous solids. We'll distinguish between the three types of solids. We will also go through a theoretical treatment and solutions of appropriate equations to come up with the energy band scheme for solids. And then using these energy bands, we will distinguish between different types of solids, metals, semiconductors, and insulators. And then from there we'll move on and cover effective mass approximation, which helps us treat issues with solids in terms of a simple theory incorporating classical mechanics. And then we'll move on to looking at cores and phonos. Then in the second part of this course, we would look at the first step and perhaps one of three important steps in top-down processes, and that step is film deposition. And to discuss film deposition, we will go through different types of film deposition. We will look at physical vapor deposition. We will also look at evaporation and sputtering as examples of physical vapor deposition. So we'll focus mainly on evaporation and sputtering. Then we will move on to chemical vapor deposition schemes or methods, followed by atomic layer deposition, and then the vapor solid growth methods. So these types or four main deposition processes will be discussed in details in this course. And then from there on, we will be looking at special categories of nanomaterials. And these nanomaterials comprise nanoparticles and quantum dots, carbon nanotubes, and nanowires. We will look into basic physical properties of these different types of nanomaterials, and we will also discuss how they're prepared. And then from there on, we move to the second important process in top-down manufacturing. And that process is pattern transfer, or what is often termed lithography. And in lithography, we'll discuss optical methods of lithography or optical lithography, and then we'll move on to beam lithography. And then that takes us to the third and last process in top-down processes, which is etching. And etching is material removal as opposed to film deposition as the first process. And in etching, we will look at wet etching, and then we'll look at plasma uses in etching and in cleaning, and we'll also look at reactive ion etching, And then we will conclude by covering edge systems, briefly discuss the edge systems that are involved. And then, before we move on to the last part of this course, we will spend some time looking at semiconductor processing and properties. And by processing we mean doping, where properties of semiconductors are electrically and optically modified. And in doping we'll discuss doping using diffusion and doping using ion implantation. So it should be diffusion and ion implantation, so I'll insert a comma here. And then we'll talk briefly about semiconductors in equilibrium, and then charge transport in semiconductors. So this part of the course focuses on semiconductors because of their importance in top-down manufacturing. And then we will conclude this course by looking at characterization, or if you like, nano-characterization methods for top-down processes. And in nano-characterization, we'll discuss electrical characterization, particle beam characterization, as well as microscopic characterization. We'll discuss those in details and cover them also with some examples. And then at the end of the characterization part, we will look into some select group of spectroscopies that are used in conjunction with top-down processes. So this is pretty much the course outline, and these course outlines will be covered in about 30 lectures or so. So that would conclude this first opening lecture in this course. Thank you.